Welcome back. Let's talk bearings, main bearings. It's a very big bearing there. I've got this screwed together, and also if you look at that, this front piece, I love working with bearings. This front piece is the bearing support. It just holds that in place. It's not going to fall forward because it's quite a tight fit. But also the nice thing about bearings is when this gear is on, that will stop that from falling out if it wanted to. This also hides the little bits of wire from the reed switch there. Then around the back, there's that bit. There are the three pieces of plastic, 10mm, 10mm and 5, and again the 5's acting as the support to hold the second, the smaller bearing in. Then what we do is get it lined up, and to assist in that I've got a leftover bit of this 10mm brass which I've tapped. And again, it's little things that you learn all the time. I'd forgotten that the little bearing at the back would rub on something 10mm wide, so rather than having a washer, I just turned a little bit down like that and it just spun beautifully. I didn't notice until I tried setting this up and realised. So I'm going to do that with the shorter bits. So that is going to go in there. I'll screw the back on, and then I'll cut this bit of wood out with a notch. I know that's at right angle, so then I can sit that on there and get this lined up and then do the same vertically, because of course there's a little bit of give and take in all these screws and bolts, so this can be set in the right place. Let's get on and do that. Right, there's the back screw just screwed into the end, and of course that holds the back bearing in place. Lovely. What a voyage of discovery this is turning out to be. So I've just noticed that once this is clamped down, the hole, the clearance hole here, is 12mm diameter. That isn't big enough to miss this centre part which rotates, so it's actually grinding round on here. Right, now this is an interesting problem, because what I need to do, I think sort of 15mm diameter will be a clearance. Drilling that out to 15mm without taking everything off is going to be interesting without destroying everything. I'll have a think. Yet another sort of drill bit, you say, or cutter. This is nice because it's for sheet material and it just has 2mm increments all the way up. So 15mm would be fine, you know. And I was thinking about, well, I could put this on the laser cutter and just get a bit bigger, but it's such a little difference. I'm going to try this, fingers crossed. In fact, I'll video the chaos that will ensue. Right, well, I've screwed that down in the hope that it doesn't flap around. What I'll also do is to put on, what I said before, the paint does tarnish if your hands get on it too much. So I will put a cotton glove on and then just, I don't quite know why, I'll slow that down. Let's see. Oh. So far, so something else. Oh, there's a little bit of chippage there, but let's see. Well, that's 15. I'll go a little bit further, a famous little bit further. That's it. Obviously, it doesn't matter about the wood. Right, I'm very pleased with that. Just a little bit of housework. Fantastic. Now, when that sits on there, that's not going to bear down on that. That's free to turn. Lovely. That's better. Perfect. The centre of the bearing is now turning properly. Fantastic. Even though this brass rod seems to be slightly bent, I rolled it down a piece of plate glass and couldn't detect anything, so it's my eyes. Right, I'll go ahead. Now I'm happy with that, and that's now set perpendicular. I will go and do that on the second one. Talk about cryptic clues. Trying to work out, and I didn't make a note of this. This is the magnet holder, just a support. It says cryptically to left. I know it goes on the back of this because I've had a look with my the first one. I was trying to work out where this would fit, how on earth you know where it goes, but it'll only fit in one place, which is there. How fabulous. The reason being, that sort of strange angle, is that as it rotates around, it will line up vertically with the reed switch that's in there to a particular point. Now don't ask me how the relationship between the engraved dial and this, I don't know, but there's one of 5 places it can go in because there's one of 5 screw holes. So, oh no, how fabulous! Even though I say so myself, of course. There's this one that works the crank or cam or whatever it is, crank pin. That's brilliant. So it only fits one way around. Oh joy unbounded. Right, I'll get them glued on and then try and find a couple of magnets and get them glued in. Then we can spin them around by hand and see whether the reed switch works. This is so exciting. This, well, sort of stuck out too far, so I put a washer and an M4 screw and just pulled that in, perfectly flush now, lovely. The reed switch doesn't hit this, it just goes past it. This then, the gear here was too far forward, it was about 3mm, 4mm different, which obviously isn't right. But of course I hadn't glued it on, I loosened the 2 grub screws, eased it back, tightened them again. What a joy, absolutely fantastic. So I'm going to glue this on through those little holes and then twist this very gently. I don't want to damage this motor. Might even get an Arduino and just quickly rig one up, perhaps wire. Yeah, I'll see how it goes, just to check that the reed switch is working. And of course I forgot to say, the other wonderful adjustment is this, so I can just slide that until they're really too tight, just get them the right distance, just tighten 1 screw or 2 screws and that's it. What a joy. Right, got a nice simple sketch set up. Oh, that bleeping is good. I've got an Arduino Uno connected to the 5V power USB supply of this, and because it's running, it's also connected to this little interface. The motor draws far too much than the power supply on the Arduino can supply, so I've got the grounds 0V commoned up, connected together, and a separate 5V supply running straight to the interface. So, and that double bleep is really good. For some reason the multimeter does double bleep when it is set into that mode, but that's great because that means that the magnet and everything else is all lining up properly. So the first time that anything is moved on this machine. Let's just go again. Fabulous, great. I'll get on and do the other one. Bells, you say? Yes, bells. Well, 1 bell for each one. These ones I mentioned got off one of the IKEA alarm clocks, which was the cheapest way that I could find to get them. Sanded them down, sprayed them up. I know you've seen all that because it's probably a couple of minutes ago on this video, but there's another day here. Now to mount them, originally I'd come up with another piece of brass that needed to be turned. That was before, for some other machines, I discovered or started using these hex spacers, which are brilliant. They're brass, you can get them in all different lengths. You can get male, female, or this is in effect male, female. So you could actually screw a load of them together if you wanted. As I say, this is M3, you can get M4 ones. I've just got 2 sizes. This is the M4 type, which I use for something different. Hold on. Yeah, so with a little bit of fiddling, cutting it down to the right size, I'm going to use these to support the bells, which is great. And in the background you can probably hear the poor old laser grinding away. And that is engraving, raster engraving, because the figures are so small and tight that it really wasn't worth doing with line engraving. So this is raster engraving, and this has so far been 37 minutes. Hence the fact in the past I said it's so slow, but the quality is absolutely amazing. So that's going backwards and forwards. I'm doing it over this side because I remember this side of the machine, plastic and stuff, not up here where the datum point is, simply because with the repeated backwards and forwards motion, imagine this drive belt going backwards and forwards, stopping and starting. I know it's got slight acceleration, de-acceleration, but I think it's just a good idea to use a different part of the drive belt for this, just moving it around the platen a bit. That's exciting to get this done, because that means I can then get the readings gear completely finished. I'm going to do the cuckoos now, because lots of that's sprayed up silver and I want to have it, give it time to set. I've got lovely drawings. Lovely. That's the bellows, which I need to adapt. And oh, that's the drive spindle and the chain, which I've just found I've got. Lovely fine chain and a pulley. First thing to do is to take it to pieces. Now, from my experience, this bit, the actual flute, is the same on all sorts of different makes of cuckoo sounders. The first thing I'm going to do is to cut it off. I'm going to slice this off on the bandsaw without damaging that, and I can't remember how I cut this off because I want the bellows and I want that. I want everything. So I think I'm going to use a scalpel to just try and gently break the glue that they used to stick it on with. I'll get on with that and show you the results. By the way, to cut this off, the bellows from the sounder, something like a strong Stanley knife is the best way, because obviously you don't want to damage this bit or that bit. And I've cut it off instead of sticky glue, the rubbery glue they use, so I'm just going to sand that very lightly on the sanding machine, both the bits. Got them apart. Now I need a way to connect this to that. And there's a story behind that. Originally I used the motor to actually pump the bellows, so the other way up, it was upside down in effect, and that worked perfectly. But then I had a problem with one of the motors that, even with pulse width modulation, so controlling its speed, wouldn't lift the bellows up, close the bellows efficiently. It would do it too quickly or not at all, even fiddling around. So then I ended up realising it had to be gravity fed, which is absolutely fine, but it meant turning the bellows the other way up, and then they got in the way of the air vent and it didn't look very nice. So I came up with this very complicated tube that carried the air down from the bellows into this with the bellows the right way up, to cut a long story short. This time, however, to try and simplify it, I'm going to try and make it from two pieces of 10mm acrylic that's laser cut with a V on the end, a mitre joint. The reason for that being, I can then drill a hole in the back here and up to it, and a hole in the back there and up to that, and then glue them together and not have ends of holes, because if they're rectangular I'm going to end up with an end of a hole I need to fill up. So let's get on and cut the bits out. So here's the plan, Stan. There's one bit, and you can see I've just marked out lightly where to drill the hole, and there's the other bit. I'm going to drill the holes and then mitre them and then glue them together. Give that a go. Right, I've drilled the little horizontal hole there, you can see. Now I'm going to try and drill the vertical one. I've got a mark here so I can line it up that way, and I'll use my eye to line it up that way. It's all very precise, this stuff. Then, and I've clamped it in a clamp from my many previous adventures where bits of plastic end up as projectiles. I think I might hold this a little bit firmer. Voila! The L's have joined up. Right, so you can see now that's linked up beautifully. I'm not going to win any prizes. That's linked up beautifully. Now if I sand a mitre on these two bits, I'll be able to glue them together and no air should escape, I think, although I may be wrong. Anyway, I'll give it a go. Well, in principle it works beautifully. Fits together and the pipe will be sealed. The only thing is, of course, I've done this the wrong way round, so it'll fit perfectly like that, but this needs to be that way. Fat chance. Interesting. But I need to make two of them, so if I do the other one, I don't know, I'll probably have to do it again. Never mind, the principle works. What an idiot. Just before I went ahead and did it, I thought, hold on a minute, could be a type of puzzle, and it was a really difficult one with the angle of the dangles. So that goes that way up and this goes this way up. And then if I lay that down and get my fingers out of the way, ooh, you can see what I'm talking about. That's worked out really nicely. Glue that together with super glue, and then this flute will go here. This bellows with its hill there, oops, will go here. So in effect that's going to stick on there. Now is that going to work? I don't know. I think I need to cogitate further. Thank you so much for watching. Hope it's been useful. Remember to click on subscribe and like and other stuff. Next time making gears and engravings and all sorts of stuff. Thanks again.